With DSAT 4.6 we can simulate crop rotations. We will use crop management data to create a new experiment that involves a sequence. In File we click on New. If we have changed weather files or added cultivars, we should refresh, and then we're gonna create a sequential file type, which means that is a sequence of crops including possibly fallow periods. We'll call it now UCCO 6601, the Institute Code, University of Córdoba, UC. And then the site code is CO for Córdoba, year 1966, and experiment number 1. This is arbitrary. That's something that we define. We can write here information about who is doing this simulation. For instance, click on Next, and then we need to add cultivars. We're gonna try and simulate a rotation of wheat and fava bean. Now in crop we go and choose wheat, and cultivar we're gonna use a Manitou. Then we add a second one. The first is gonna be a fallow period, and then we add a fava bean crop, cultivar Alameda, and then we add another fallow period. Click on Next. Okay, in general we're gonna use a field that implies weather and soil. Let's call it the same as the experiment, UCCO, University of Córdoba at Córdoba, and 6601 would be experiment number 1, year 66, and the weather station is gonna be UCCO, that are weather data in Córdoba. And here we look for a weather file that we have already prepared that has Córdoba data, UCCO, from 1964, including 50 years. We need to add a soil. We're gonna assume a default medium sandy loam. The surface texture is sandy loam, and the depth is 150 centimeters. We assume that there are no stones on the surface. We click on Next, and then we need to define the planting. That makes sense in the case of the two crops. So we're gonna produce planting for wheat, and then we will be planting in principle December the 1st, 1966. Planting method would be using dry seed, and the planting distribution is in rows with a row spacing of 20 centimeters. The plant population is going to be 200 at sowing and 200 at emergence. We assume that there are no losses of plants from sowing to emergence. We assume that the rows are north-south oriented, so here we write 0 degrees for north. and the planting depth for wheat is going to be 3 centimeters. We're going to add another one for the fava bean crop. In this case, we would be planting, for instance, on October 15, 1967, also using dry seed in rows. Now the row spacing is going to be 40, for instance, and we're going to have a plant population of 20 at sowing, 20 at emergence. The planting depth can be 5 centimeters. We click on OK. OK. So far, we have included cultivars and planting for the two cropping periods. Let's add a harvest for the periods that include fallow. So we write fallow, and we have on reported date, let's consider that the fallow will be ending by September the 1st in 1966. We click on OK, and now we go to treatments. In treatments, we're gonna be first, we have a wheat crop using cultivar Manitou of wheat, field number 1. We have not defined yet the initial conditions, but we will do soon. We have defined the planting. We don't have irrigation. Okay, we need to add a fertilizer application at planting. We are not going to use organic amendments or chemical applications. We will incorporate tillage later. We won't perform environmental modifications, and we do not specify harvest at this time. We add a total of 4, because first we have wheat, second we have fallow, third we have fava bean, and then we have wheat. In this case, the second one is gonna be 2, which is the fallow. Then we have fava bean, which is 3, and then we have fallow again. Okay, we click on OK. We need to define still the initial conditions and fertilizer for the wheat crop, which is first in the rotation. So we go to management, click on fertilizer, and let's say that we add at planting, days after planting, 0 days after planting, we're gonna add, for instance, 50 kilograms of nitrogen as urea. We band it on surface, put here 1 centimeter depth and 50 kilograms. We don't add any other one. So this would be nitrogen at wheat planting. Click on OK. We need also to define, as we said, well, we'll go to treatment and make sure that we incorporate that. Click on fertility here, and then click on nitrogen at wheat planting. We click on OK and go back to management. to environment, and then to define initial conditions. And then this is the conditions that we find at wheat planting. The measurement date is the 4/12, the 1st, 1966. The previous crop has been faba bean. We can write here the root weight, for instance, 1,000 kilograms. We don't know the nodule weight, we have nothing. And crop residues, for instance, we have 500 kilograms. The percentage of nitrogen in the residues is going to be 1%. We click on OK. Then we go to treatments, and then we go to initial conditions for the wheat crop, and then we click on at wheat planting. Remember that we need to define the end of the harvest period. In harvest, we have defined this date as marking the end of the fallow period. So we incorporate it as the harvest condition here and here. Okay. Well, we have most of the information. Now we go to simulation options. The simulation planting date, we said that would be 12/1, 1966, and for the second crop would be this one. In simulation options, we can define many things that would override what we have already defined for management or environment. But it's important to go through them to make sure that we have chosen correctly the options for simulations and the options for management. The simulation start date would be when the models start working. We're gonna assume that the simulation starts on September the 1st, 1966, which is sooner than the sowing of the wheat crop. We start on this specified date, and we're gonna be running total of 20 years with one replication. Why one replication? Because we are using actual weather data, and a number of replications different from one is okay when we are going to be using generated weather data. Okay, then we click in options, and we see here, this is, as we are dealing first of all with wheat, we're gonna be using the water balance, the nitrogen balance. We don't have symbiosis for nitrogen. We don't simulate phosphorus, potassium chemical diseases, but we might include tillage later. We click on OK, go back to simulation options. We were already in options, then we go to methods. We're gonna be using actual weather data, measured data, initial conditions as reported. The most of these options might be left as they come as default, But for instance, there are some that are especially critical. For instance, in the case of photosynthesis, not all the models would use leaf photosynthesis based on hourly data. Better you use canopy curve daily. Hydrology, we leave rich water balance. The method for calculation of soil organic matter might be changed to Ceres-Godwin, and we leave the soil evaporation and the distribution of soil evaporation as they are. Then in management, this is an interesting point, we can add some information regarding to the main management options. Like planting, we can choose between planting on a given specific date or using an automatic criteria. We said before that we would be planting wheat in December the 1st. But let's consider that we can be more flexible than that we can plant from November 15, 1966 to December 15, 1966. So the model would perform planting whenever within this time window the conditions of soil temperature are between 40 and 10 degrees and soil water is between 40% or 100% fill capacity in the 0 to 30 soil depth. We could change also these conditions, but let's keep them as they are. We're gonna be in the case of irrigation water management, we have no irrigation. This is a rain-fed this is a rain-fed rotation. And then for fertilizer, we are using days after planting, and we have already defined that at 0 days after planting we apply fertilizer. We don't have organic amendments, and we will harvest at maturity of the crop. We could also harvest using an automatic criteria, but let's keep it at maturity. Okay, now we're gonna be defining the outputs. It's better not to be restrictive with that. Let's put all the possibilities that we have. Summary, yes. Growth, yes. For carbon, yes. For water, yes. For nitrogen, yes, but not for phosphorus. This is chemical or operations. Consider the normal output. Okay, so we have defined everything related to this first simulation that is related to wheat. Let's add a second simulation options for the fava bean crop. We go to this second level and we check on general. We have the start date, the number of years. Here we have symbiosis, but we keep everything else exactly the same. In methods, we have already defined what we want. Management, we are gonna be performing automatic planting, but in this case the dates for planting are gonna be from October the 1st, 1967 to October 31st, 1967. 7. We will apply the same criteria for planting. Here, the most critical condition for planting is going to be water available in the soil, as many times an autumn crop might be limited for planting due to the lack of rainfall in the autumn. In the case of fertilizers, the faba bean crop is not fertilized and the harvest is performed at maturity. Okay, then we go back to treatments, and then in simulation controls we add 1 for wheat and 2 for faba bean, and we're gonna need another 1 for the fallow period. So we click on OK. Going back to simulation options, we add a third level, which is gonna be called fallow, where in options we don't have symbiosis, and everything else is the same. Click on OK, and then in treatments we add here simulation control fallow and fallow. We click on OK, and we could now add, if we want, some tillage. For instance, tillage will be performed during the fallow period, after harvesting the wheat before planting the faba bean, or after harvesting the faba bean before planting the next wheat crop. Excuse me, this should go as fallow. Okay. Click on OK. With that, we go and we save as. In principle, it will assign the name UCCO 66 because it starts on the year 66 and 01. We click on save, and then we got it ready for performing simulations. Going back to simulation options, to make it clear, when we write here that we want 20 years of running the model, as we have a rotation, a 2-year rotation, that means that during 20 years we will have 10 wheat crops and 10 faba bean crops. And then we will have fallow periods in between. Before saving the file, we're gonna make sure that the conditions defined for ending the fallow periods have been defined as follow are right. It says here on reported dates we end the fallow period. The same goes for the second fallow period. Then we go to simulation options, and then in fallow we check on management, harvest. It says harvest at maturity. It should have the same criteria that we have already defined for ending the fallow period on reported dates. Click on OK. Check on treatments that we have already defined. Harvest, this is fallow, harvest, the second fallow, and we have the simulation control for wheat, for fallow, for faba bean, and then for fallow. Click on OK, and we are done. Go to File, Save As, and it will be saved at UCCO6601.SQX. Click on OK. Save. Now we might go to this app and try go to sequence. Here we have the 6601. Click on run. Click on run model. And then the simulations are completed. We click on analysis, and if we are lucky, another window appears telling us a summary. The experiment title, UCCO 6601, starting year 66, ending year 85. It has run during 20 years. The number of runs is 40, because we have run for every year that we have one crop and one fallow period, only one replication, total of 40 runs, and 40 runs for this rotation. We click on OK, and now we can proceed. Well, usually click on save for the outputs, and then we have another window showing us different outputs from the sequence simulation. Here we can have a look at different data. We can have a look at the summary data, for instance, for the harvested yield. Use summary data for wheat, a mean value of close to 3 tons, for faba bean close to 2 tons per hectare, and this is the standard deviation, values minimum and maximum. Note that there is 1 year with faba bean yield 0. Maximum yields are exceeding 4 tons per hectare. We can also have a look at the time series with the crop wheat or faba bean. There are 3 instances of faba bean having 0 yield. Okay. If you are interested, we have added a link to this video that includes different sequence files for TSAT46. Those are UCCO 6401, 02, and 03. And one describes a wheat faba bean rotation, the second describes a wheat after wheat rotation, and the third a continuous faba bean rotation. The link to this file, including these 3 different sequence files, is added to the video.